Namaskar friends, myself Dr.Jayvir and today we are going to learn about how to measure the temperature of the sun. Isn't it interesting? Let's count it out. So, in order to measure the temperature of the sun, we need to have certain assumptions. Let's see what kind of assumptions that we require. As we know, the sun and the distance between the sun and the earth is something that we should know before solving this example. But sun is a radiative entity. So in order to find out the radiation coming out from the sun in terms of heat, the equation is E sigma A T raised to 4. Now we need to know all the other terms except temperature. Why? Because temperature is our concern. So what is the distance between the sun and the earth? That is 1.5 into 10 raised to 11 meter. And the emissivity of the sun is equals to 1. Actually it is 0.99. Emissivity is the amount of energy emitted by the radiative body, that is called emissivity. That is the count of emissivity, correct? Again, the intensity of solar radiation at earth is, suppose assuming that I is equals to 1.36 kilowatt per meter square. So earth is at a certain distance from the sun. So whatever will be the body which is at a distance of 1.5 into 10 raised to 11 meter, the sun is radiating the same amount of energy on that particular entity as it emitting on earth. So that is, we are assuming 1.36 kilowatt per meter square. And radius of the sun, that we need because we want to find out the area of the sun. So radius of the sun is nothing but 7 into 10 raised to 8 meter. So let's find out the temperature out of it. So I can put it here that Q, suppose Q. So what is Q? Amount of Q. How to find out Q? So Q is nothing but the intensity I into area between the sun and the earth. As I said, we need to consider sun as a radiative entity and earth as an absorption of the radiation entity. So the area between sun and earth means we need to assume one sphere in between sun and earth, which having radius 1.5 into 10 raised to 11 meter. So what is the area of the sphere? Area of the sphere is 4 pi r square, where what is r? That is 4 into pi into 1.5 into 10 raised to 11 square. So this is the area of A between the sun and the earth. What it means? Any body which is surrounded by the earth and which is at a distance of 1.5 into 10 raised to 11 meter in the spherical path, the sun will radiate the same amount of energy on it. Let's count it out how much it is. That is 4 into pi into 1.5 into 10 raised to 11 square. That is coming around 2.827 into 10 raised to 23 meter square. And ultimately the value of Q will be, that is 1.36 I into area of the AC, which is nothing but 2.827 into 10 raised to 23. So multiplying it with 1.36 which is nothing but kilowatt, we need to convert it into watt. So it is 1.36 multiplied by 10 raised to 3 multiplied by 2.827 multiplied by 10 raised to 23. Why I am putting here 10 raised to 3? Because we want to convert kilowatt into watt. So Q is equals to now 3.845 into 10 raised to 26 watt. So when watt per meter square multiplied with meter square, the final unit will be watt. Okay, so we are having the value of Q now. The value of emissivity is given here. This is nothing but emissivity E. So E is equals to 1. The value of the Stefan-Boltzmann constant is nothing but 5.67 into 10 raised to minus 8 watt per meter square Kelvin raised to 4. This is a standard value. So we are having the value of sigma now. So what we require? Area of the sun. So area of the sun can be found out by using this equation 4 pi r square. But what is r here? Radius of the sun here. So let's find it out. That is 4 into pi into radius of the sun, nothing but 7 into 10 raised to 8 square. So 4 into pi into 7 into 10 raised to 8 square, which nothing but 6.157 into 10 raised to 18 meter square. So now we are having all the values. So let's find out the final value of the temperature. So putting all the values in this equation, so Q, instead of Q I am putting 3.845 into 10 raised to 26. It's actually 10. Okay, is equals to E is nothing but 1, sigma is nothing but 5.67 multiplied by 10 raised to minus 8 into area of the sun, which is nothing but 6.157 into 10 raised to 18, and again temperature of the sun raised to 4. So let's find it out. What is the final value over here? So 3.845 into 10 raised to 26 divided by 5.67 multiplied by 10 raised to minus 8 multiplied by 6.157 into 10 raised to 18. So the final value is the temperature raised to 4 of the sun is equals to 1.1014, and by taking the 1/4 part of it, it is coming around temperature of the sun. This is nothing but 5760.84 Kelvin. So this is the temperature of the photosphere, and this is how it is calculated. I hope you enjoyed it. Thank you very much and have a nice day.